Algebra 1, section 12.4, dividing polynomials. Remember back when life was simple, I'm thinking like maybe third or fourth grade, and you were given a problem like this? Yeah, that's not what we're going to be doing today, but I just want to remind you that. No, well, actually, we're going to do something that builds off of this concept. But let me just remind you, in case you forgot, that what you would do, what this problem is saying is to divide 726 by 6. Divide 6 into 726. And what you did is you ask yourself, how many times does 6 go into the first number? 6 goes into 7 one time. You put the 1 right here. And then the process was to go 1 times 6 equals 6. And that goes here. And then what you're going to do is subtract down and get 1. And then you drop the 2. Okay? And then you ask yourself, how many times does 6 go into this number? 2. 2 times 6 is 12. And you get, in fact, a 0 in this case, but you need to bring down the 6. And how many times does 6 go into 6? 1 time. 1 times 6 is 6. When we subtract down, we get 0. And that would mean that the remainder, if you remember that number, remember that term, remainder, here is 0. Sometimes, if your elementary education was like mine, the first time through long division like this, we would put R and then whatever the remainder was. And if it's 0, you don't really have to include that. But then the second time through, maybe like fourth grade, and I'm kind of guessing at the grades, but maybe that was right. When you started to understand better what a fraction was, you actually put that number over the divisor, right? So this would really be 121 and 0.6. Okay, now that'll make more sense when I do this problem. So you ask yourself, how many times does 4 go into 1? 0. So then you look at the next digit in. How many times does 4 go into 11? Well, that would be 2. 2 times 4 is 8. Subtract down. 11 minus 8 is 3. Drop the 3. How many times does 4 go into 33? Well, 4 times 8 is 32, right? So it's going to be 8. 8 times 4 is 32, and the remainder is 1. Now, again, there were two ways to present this, and the Algebra 2 book actually does it differently than the Algebra 1 book. What we want you to do is to take that remainder and put it over the divisor. So really, our answer here would be 28 and 1/4. Okay? 28 and 1/4. Not 28 remainder 1, but do the fraction. Anyway, that's what we're going to apply here to problems like this. Okay? And for this first one, it's actually not going to be long division, but I want to do this one because I want you to pay specific attention to the answer that we get. It says divide this polynomial here by 3x squared. When it's just a monomial, when the divisor is a monomial, we don't need to do the long division that I just showed you. And instead, all you need to do is divide each term by the divisor. In fact, let me show you their work, because their work's slightly different than mine. You see how they have that polynomial multiplying 1 over 3x squared? If you're dividing this by 3x squared, you're multiplying by its reciprocal. That really builds off of lesson 12.3. Okay, so with that in mind, I'm just going to go ahead and divide each one of these by 3x squared. That's what would happen as you multiply each of them by 1 over 3x squared. And then we'll just come back through and simplify each. Okay, so 18 thirds is 6x to the third divided by x squared would be x, so we're going to have 6x here. 9 thirds is 3. X squared divided by x squared is 1, so that's just 3. And 15 thirds is 5, and in this case you've got x over x squared. That would leave an x in the denominator, so this would be 5 over x. So just take a note as to what the answer actually is. You've got a linear term, a constant term, and really this is an x to the -1 term if you stop and think about it. Remember move it and lose it from chapter 8. That's kind of what you have. So you do have descending order. Degree 1, degree 0, in a sense, degree -1. Okay? Now notice something. Before we move on, we're going to do 3 more examples, but just notice this. What I'm trying to point out, the degrees, is that you had a term here that was degree 3. You divided it by something that was degree 2, and your resulting term in that space is degree 1. That's not a coincidence. Something that's x to the third divided by something that's x squared is going to be x to the first. That's the linear term. That's why it's degree 1. This one got divided by a quadratic. Quadratic divided by a quadratic is just a constant, and we already talked about what happened in that last one. All right, so how does the long division play in? Divide 5x squared plus 2x minus 3 by x plus 2. Here's what you're going to do. You're going to want to write every problem like this way. Use that old symbol that you learned in elementary school for division and do this. And the thing you want to ask yourself is, how many times does the first term here go into the first term here? Okay, forget about the plus 2. That doesn't really matter right now. You're asking yourself, how many times does x go into 5x squared? Okay, and the answer to that is 5x. And I'm going to pause on that and let you think about that. If I divide 5x squared by x, I'm left with 5x. Okay? And the reason we need it that way is because when you multiply around, just like I showed you at the beginning, you're going to multiply this by this, this being a binomial now. This is why this problem is different than the last one. When you multiply 5x by this binomial x plus 2, you're going to get 5x squared in this position right here. That's what we need, because the next step is going to be to subtract down, and we need that to be 0. Okay, so that's why we really don't worry about the plus 2. We're only worried about what number. Really, it's a number variable exponent combination that when multiplied by x gives us the same thing here. Okay, now whatever the other multiplication is, you just have to go with what you have. 5x times 2 is 10x. All right, now caution. When students make mistakes with polynomial long division, this is the place where I see mistakes made most often. You are subtracting down. 5x squared minus 5x squared will give you 0. That has to happen. But be careful here. 2x minus 10x would be negative 8x. It's very easy to subtract the wrong way or to add when you meant to subtract, but that's not correct. Okay? So that's negative 8x, and then we're going to bring down the negative 3. Remember when we dropped that, the next digit? That's kind of the same thing we're doing here. And now you're asking yourself, how many times does x go into negative 8x? Well, that would be negative 8, because negative 8 times x is negative 8x. And then also negative 8 times 2 is negative 16. And again, pay attention to this now. As we subtract down, very important that you understand subtract. Subtract down negative 8x minus negative 8x. Minus negative means plus, so negative 8x plus 8x is again going to give me 0. And once again, that has to happen for us to be doing polynomial long division correctly. Now, negative 3 minus negative 16 is positive 13. Okay, so what's our answer then? Well, in one sense, it's 5x minus 8, remainder 13. Okay, the way we want you to write this is 5x minus 8 plus the fraction 13 over x plus 2. Okay, now somebody might ask, why is it plus? Think about it like this. If you ate 1 1/3 pizzas, now don't do that in one sitting, but let's just say you ate 1 1/3 pizzas. That's addition, right? Maybe you ate half a pizza the first time you sat down. Maybe you ate another half the next time you sat down, and then maybe you ate a third of one the next time. You ate half plus a third, which is 1 1/3. That's the same thing we're doing here. This is 5x minus 8 and also 13 over x plus 2. So you do want to add it. This is the correct answer right here. And again, I'll point out what our answer to the first problem was. This is similar. You've got a linear, you've got a constant, and then you sort of have something that's to the negative 1 degree. 3 terms. Okay? We'll do that a couple more times. Confirm the answer there. 5x minus 8 plus 13 over x plus 2. That's what we got. All right, so then they'll try to apply this to a rectangle, but it's really the same thing, right? Because you know that length times width is going to give you the area, right, on a rectangle. So really what we're doing is we're dividing 2x minus 3 into 6x to the third minus 5x squared minus 9. Okay, caution though. Do you see that there is not an x term there? There is not a linear term. We need to hold that place value. You want to put a plus 0x in here, minus 9. If you don't do that, you will not get the correct answer. We need these always in a descending order, both of them actually, right? This is in descending order, standard form, linear. And this is in descending order as well, to the third, to the second, to the first, and to the 0, right? This is like saying minus 9x to the 0. So this is really 0 degree. This is the first degree. Just so happens that there wasn't a term in there, so we assume that its coefficient is 0. Okay, so we're dividing. Here goes. How many times does 2x go into 3x to the third? 2x go into 6x to the third. That would be 3x squared. 3x squared times 2x is 6x to the third. Remember, add the exponents. Now you need to multiply here. This would be negative 9x squared, and subtract down. When you subtract down, if you've picked the right expression here, the right term to put here, you will get 0 when you subtract down. That's a guarantee. So assume this is 0. Negative 5x squared minus negative 9x squared is 4x squared. Be careful with the minus and negative. Okay. Then we're going to bring down that plus 0x. And even though it's 0, we still need to bring it down and go through the process one time to get that, what is going to be the linear term here. How many times does 2x go into 4x squared? Well, that would be 2x. 2x times 2x is 4x squared. 2x times 2x is 4x squared. I just said that. And then 2x times negative 3 is negative 6x. And subtract down. Here's 0. 0x minus negative 6x would be 6x. Okay? And then finally, well, and then we bring down the negative 9. Then finally, we're going to try to ask ourselves, how many times does 2x go into 6x? Well, that would be 3 plus 3. 3 times 2x is 6x. 3 times negative 3 is negative 9. Look what happens. 6x minus 6x is 0. Negative 9 minus negative 9. I always like jump over here because I always kind of imagine there's a subtraction symbol here. But if you do that, just keep in mind that this is a quantity, right? So it's minus 6x minus 9. Minus the quantity 6x minus 9. That's why negative 9 minus negative 9 would be like saying add. You're going to get 0. The remainder is 0. Okay? So what's our answer? Our answer is this right here. It's 3x squared plus 2x plus 3. All right, now let me ask you kind of a conceptual question. The remainder ended up being 0. Was there any chance that we would have gotten a remainder of something other than 0? If you're thinking on the right level, the answer would be no, because it's a rectangle problem. Obviously, we need a quadratic polynomial that when multiplied by 2x minus 3 actually does give you 6x to the third minus 5x squared minus 9. Okay, so it needs to be divisible. That area needs to be divisible by our answer. No different than if we had a rectangle that was 4 by 7. Okay, well, 28 would be the area, and 28 is divisible by 4 to give you 7. 28 is divisible by 7 to give you 4. Okay, a different way to say that would be to say that if I multiply 2x minus 3 by the answer that we got here, you'll get the area. All right, one more problem today. Divide negative 8x minus 2 plus 6x squared by the quantity negative 1 plus x. The first thing I would do is switch all of that around so that you have standard form descending order. So negative 1 plus x is x minus 1. That's what's being divided into this expression, which I'm going to write as 6x squared minus 8x minus 2. And then from there, the process is exactly the same as the last two problems. So I'm going to go quick. This would be 6x. This would be 6x squared minus 6x. Subtracting down to get 0 here. Subtracting down to get negative 2x here. Bring down the negative 2. How many times does x go into negative 2x? That'd be negative 2. Negative 2x. Plus 2, right? Okay, so be careful. I got to go a little slow myself, just make sure I don't make a mistake. And negative 2x minus negative 2x will give you 0 here, but negative 2 minus 2 is negative 4. Okay, it'd be really easy to make a mistake there and think that it's 0 when there actually is a remainder of negative 4. Now, again, let me say, In one sense, the answer could be 6x minus 2, remainder negative 4. Yes, some textbooks would have you list it that way. Our textbook does not, so because I'm asking you to, and also because you'll want to check your answers and have them in the right form, our answer actually is 6x minus 2 minus, well, you might, two things. You could say plus negative 4 over x minus 1. That would be perfectly fine. I tend to put the negative out front, so really I would say 6x minus 2 minus the fraction 4 over x minus 1. I'm sure this is the way that the book answers would list them as well. Okay? So that's all. Let me just check that answer real quick. Minus 4x minus, yep, that is correct. Good luck on your homework. Thanks for tuning in.